A simple random sample of size 64 is obtained with a mean of 79 and a standard deviation of 16. And we first want to describe the sampling distribution of X bar. So in order for us to do that, we first need the mean. Okay, we need the mean. And due to the fact this is the sampling distribution, this is going to be the mean of X bar. That's going to be equal to 79. The second thing we need is the standard deviation. Standard deviation. So this is going to be standard deviation of X bar. We are taking the population standard deviation of 16 and dividing by the square root of the sample size of 64. This makes 16 over 8, or 2. And the third thing that we need is the shape. Which means we need to check if our sample size is 64, if that's going to make a shape that's approximately normal. But 64 is, well, much greater than 40. So the shape is going to be approximately normal. I say approximately instead of exactly due to the fact that this is a sampling distribution. It's probably going to be a little bit off, but for our sake and purposes, approximately normal is perfectly fine. So, with that being said, we could calculate these two probabilities then. For the second one here, we want the probability that X bar is greater than 82.5. So probability X bar greater than 82.5. Okay. So the picture that corresponds to that, draw that here. We have a mean of 79, and we want 82.5. 82.5 would be, let's say over here-ish. And don't worry, wherever you put the number in relation to the mean, the amount of distance you put between them, technically speaking, does not matter per se, as long as you know that 82.5 is supposed to be to the right of that, and, well, standard deviation is 2. This needs to be greater than 1 standard deviation away. But the exact location of it is not going to matter per se too much. But we want the area, though, to the right of this. So this area here in red. Very small area. But this, instead of Excel, since we want the area to the right of that, it's going to be 1 minus norm dot dist of 82.5 comma 79 comma 2 comma true. And typing that into Excel, let me switch over to that. This is going to make equals 1 minus norm dot dist of 82.5, 79, 2, and true. Okay. Typing that in gives us a probability of about 0.0401 rounded. 0.0401. Then for the probability between 76.8 and 83, that, just to give myself more room, I'll write that down here. So that was a mean of 79. 76.8 would be about here-ish. And 83 would be over here. And as you can tell by my terribly drawn picture, it should be a pretty good probability, right? It encompasses a lot of this normal distribution. So, this calculation, due to the way Excel is, we need to take the probability of being less than 83. So norm dot dist of 83 comma 79 comma 2 comma true. But since we want just this area here in red, we need to subtract the area less than 76.8. So minus norm dot dist of 76.8, 79, 2, and true. Okay, so we need to type the entire thing there into Excel. So going back into that, this will be is equal to norm.dist of 83, 79, 2, true, minus norm.dist of 76.8, 79, 2, true. Putting that into Excel indeed gives us a pretty good probability amount, 0.8416. So this is equal to 0.8416.